Yes, we are live now. Please start.
Good evening, everyone. Very happy to connect with all of you today. I welcome all of you to this live session on beautiful mathematics. And I'm Balraju from IIT Pravartak. And we are going to have a very interesting session today from Professor Rajesh Sadagopan. I want to introduce him before we get into the session. Mr. Rajesh Sadagopan is the founder of Aryabhatta Institute of Mathematical Sciences and has been teaching mathematics for the last 30 years and has been inspiring a lot of students above the age of 10 and giving this interesting course on out-of-the-box thinking through mathematics. It's called OOBT, popularly known as out-of-the-box thinking through mathematics. And this is being offered as part of IIT Pravartak courses. And a lot of students have been registering for these courses. Many schools have been, benefiting from these courses. And I'm very happy to have Professor Rajesh Sadagopan today to deliver this session on beautiful mathematics. Welcome all of you for this session. And over to Professor Rajesh Sadagopan to deliver his interesting session on beautiful mathematics. I'm sure a lot of students are waiting for your session, sir. Welcome for this session, all of you. Thank you, Professor Rajesh Sadagopan, for accepting to do this session. Over to you, sir.
Okay, thank you, Balraju, sir. Let me share the screen.
So one instruction for all the students, if you want to post queries, there is a Google form in the description of this YouTube video. Please post your queries in that Google form and it's shared with Professor Rajesh Sadagopan. He will be answering the queries from the Google form. Thank you, sir. Over to all of you. All the best for the session.
Thank you. Okay, namaste to one and all, and hi to everyone. So this is going to be a very interesting session, I hope. And of course, mathematics is very beautiful, and mathematics is a big ocean. And I'm going to tell only from my perceptions that what I have seen, mathematics is beautiful. So I'm the course instructor of OOBT IIT Pravartak. So this is a free online session, and this is for students, teachers, professionals, etc. And we have little time, over 90 minutes. And I'll try to cover as much as possible. So what I'm going to do today is, in this session, is I'm going to tell about mathematics in a different way. Of course, some of you might have already known a few things, and those who have done OOBT and all, but when I come across a lot of people, it's going to be different. And I have learned from other people also something different. I have also contributed different. So we have to work together in bringing out some different dimensions of mathematics. And so please listen to the lecture carefully, and then you can post your queries. We'll try to answer as much as possible. So I have a lot of slides. I might have to skip a few also. I'll try to show as much as possible. Okay, so we are going to see something called interpretation. Interpretation means how we look at things. One is fixed, other one is varying. So fixed and varying. Fixed means that we have some kind of interpretation. We always think the same way. And varying is something we have to look things differently. So this is a very simple example in mathematics. And so let me show you. So this is, you can see that the rectangle is divided into 8 equal pieces as shown. And you can see that a shaded portion is 1 by 8 and the whole is,
Sir,
you have 8.
Sir, you need to share the screen, sir. We can see only the slide now.
Oh, sorry, one second. I think I have, yes, I'm sorry. Is it okay now?
Thank you, sir. Now I can see.
Yeah, sorry. I think I pressed something. Okay, I'm sorry. A rectangle is divided into 8 equal pieces as shown. And you can see that the rectangle is divided into 8 equal pieces. One of the pieces, the leftmost piece is shaded and it shows 1 by 8. That's fine. That everyone knows that we have been asking. But remember, I am telling fixed versus vary. That's the point. Okay, I've got a slider. What I'm going to say is, this screen, whatever you see, whether the screen is full or the rectangle is whole. And the laptop screen is a part of the laptop. Is the laptop the whole? So what is whole? Whole is an interpretation. If I take all the 8 pieces together as a whole, and one of the pieces, of course, 8 equal pieces, therefore one of the pieces 1 by 8. So I'm changing the interpretation. You now see, I'm changing this B, which is the number of pieces taken as whole. You see now, can you see on the screen that 8 got changed to 7? Otherwise, you can see the whole is 7, and now the shaded is 1 by 7. 1 by 7. Okay, so it is our interpretation, mathematics. So this is what we need to think. All of us know about the shading is 1 by 8 and all we've been doing for years. But this is very important because now you see the number of shaded pieces I'm going to change by moving the slider at the top. So you can see now 2 pieces shaded 2 by 7, 3 pieces shaded 3 by 7, 4 pieces shaded 4 by 7, 5 pieces shaded 5 by 7, 6 pieces shaded 6 by 7, 7 by 7, and 8 by 7. And interestingly, this 8 by 7 is nothing but 1 whole and 1 by 7 because the whole contains 7 pieces. So it's something to do with the mixed fraction. Okay, I can change now. Second, I can change now the pieces to, for example, 5. Okay, now you can see the whole contains 5 parts and the shaded is 1 by 5. If I'm going to change this 2 by 5, 3 by 5, 4 by 5, 5 by 5, 6 by 5, 7 by 5, and 8 by 5. So it is, and now you can see that 1 whole and 3 by 5. So it's an interpretation. That means the very first piece which we are shading is 1 by 8 if you take all the 8 pieces together as a whole. So this changing, interpreting is the same piece. For example, I have seen the kits and other things and all. So we can think of in the lab with the same set of pieces, we can do different interpretations and to teach the concept, for example, like mixed fraction. So here I am telling fixed and varying. So we can vary the same figure with the different interpretations and we will get some results. For example, I can do now, 1 second, this is 1 by 3 because the whole contains 3 parts and 2 by 3, 3 by 3, 4 by 3. If I shade everything, it's 8 by 3. Now it contains 2 wholes and 2 by 3. So that's all. That means that is the interesting part. How you interpret things is very, very important. So fixed versus varying. So this is what is out of the box thinking. We can think differently. And this one, actually, I'm telling only from students as well as teachers. And in fact, the other people also should know that. That means whatever we are seeing, not with respect to the fraction concept or anything, you can interpret in different ways. So that is one important art. That is, I see mathematics like that. So that is one thing we have seen. Opinion versus fact. This is very important because this mathematics teaches us opinion versus fact. Because even in life, we come across a lot of opinions. We don't know what is the fact. Even the media news we are getting from different medias, and we don't know each of them tell in their own way, or sometimes the exact opposite. Okay, whatever it could be. And we don't know which one are opinions and which one are facts. So that's very important. So we need to develop that. In mathematics, we can see this with an example, opinion versus fact. So I will try to go a little bit quickly. At the same time, I will not go very slow also. Pick the odd man out is a very important thing that we come across in mathematics. So as you see that in the pieces, only one piece is colored differently. That's the odd man out. So odd man out means which is different from others. So here is pick the odd man out. And you see that 2, 11, 23, and 35. If you're going to pick an odd man out, you can see 2 can be the odd man out, one can say. For the reason 2 is the only single digit number, or 2 is the only a single digit number, or you can say that 2 is the only even number. So there are 2 perceptions. But in either way, 2 is going to be odd man out because it is all other numbers are 2-digit numbers, or all other numbers are odd numbers. Okay, that's fine. That's correct. 2 is the odd man out because it is different from others. If somebody tells 35 is the odd man out, that is also correct. Why? Because 35 is the only composite number. 2, 11, 23 are prime numbers. So 35 is also equally good. Okay, and then one can say 11 is the only number with repeated digits. Therefore, this pick the odd man out is each of the number will be different from its others in its own way. Just like you have 4 persons are studying in some institute. If you try to go by gender, one person will be odd man out. If you go by the nationality, another person may be the odd man out. If you go by the the course that they are doing, okay, and one person the other person may be odd man out. So in what aspect you are looking, it matters with the odd man out. Therefore, this odd man out is more of an opinion question than a fact question. Okay, it is like, what is my favorite color? If I ask that, red, blue, green, purple. Okay, so it's you don't know what is my favorite color. In fact, my favorite color could be yellow, which is not a part of these options. Therefore, we should understand we need to differentiate between opinion questions and fact questions. Opinion questions are something like, so if I ask which ice cream you like, okay, that may vary from person to person if I put the same question before everyone. Okay, so for example, mathematics is beautiful for me, but for some others, it may not be. Okay, but the point is, since I have sensed mathematics is something beautiful, so I am trying to only propagate that. So that's all I can do. So it's like everybody has got an opinion, but what is the fact? That's the point. So this is an opinion question. And so we need to differentiate between opinion and fact. Okay, so think differently. This is thing. So let's take numbers 11, 22, 33, 44, 55, 66, 77, 88, 99. What is the next number? Most of us will say 110. It's okay. 110 because it looks like the numbers goes in multiples of 11 in strictly increasing order. And so 11 first multiple is 11, then 22 like that. After 99, it should be 110. So that can be guessed. Most of them will guess that. I am not telling it's wrong. Like the previous one, where every number has a possibility, chance of being an odd number is the correct mathematical answer. I am not telling 2 is the right answer, 35 is the right answer. Every number has a possible, being odd man out. Like that, 110 is one possible answer. I'm not telling 120 is wrong. 110 is a possible number. Answer may contain many possible numbers. One number is not one answer. You need to understand that is another illusion we have. We have a lot of opinions while learning mathematics. So 110 is a possibility. 111 is also a possibility because one may write natural numbers with repeated digits in increasing order. Let me repeat, with repeated digits in increasing order without leaving any number. All natural numbers that contains repeated digits are written in strictly increasing order. So we need to at least have 2 digits. So 1 repeats, 2 repeats, like that, 9 repeats. Then 0 repeats won't come because we are writing natural numbers. So we'll go to 111. That's the next number. Okay, so therefore, we cannot make again assumptions. The fact is 111 is possible with a rule, 110 is possible. The 2 different rules may get the same. The first 9 numbers are going to be the same. In fact, any number could be the next number, can be proved algebraically at an elementary level. I can even bring -2/3 as the next number. You're surprised. But that is the story. So, but this is a very simple way of explaining things, that 111 could be the next number. So sequence may progress with repeated digits also. Okay, now I'm going to tell you about working patterns versus not working patterns. In mathematics, there are working patterns. There are not working patterns. Working patterns are the patterns that's going to work. Okay, by especially the number patterns we see, and not working patterns. So therefore, how do you find them? But that's the point. So it's like the sequence already told, but I am going to show you a number patterns that is done by a 3rd standard and 5th standard kids in a national conference under the guidance of myself and another elder person. So this is about splitting numbers. I can show quickly because, so splitting numbers means here natural numbers is split into natural numbers only, but splitting means you can take as it is also. And the order is also taken into account. So for example, you see 1 equal to 1, 2 is 2, 2 is 1 plus 1, and only natural numbers. So you can't have 1.5 plus half like that. And 3, you have 4 ways. 1 plus 2, 2 plus 1 is different from 1 plus 2 because order is important. And then for 4, it is going to be, you will have a lot like this. Okay. Now, the point is these children, please remember, these are children of 3rd standard and 5th standard. They were presenting a paper in a national conference under the guidance of myself and another elder person. The interesting part is they found that for 1, it is one way. Splitting means they can take whole, this full number also. And for 2, it is 2 ways. For 3, it is 4. They took 4 as 2 into 2. The simple reason, because for 4, you can see these are the 8 ways for 4, and they found that 8 to be 2 into 2 into 2. And 5, they found it is 2 into 2 into 2 into 2. That is 16 ways. So therefore, in general, for n, it will be 2 power n minus 1. So something like that they were able to derive. So a working pattern, they verified. It is wrong, nothing wrong. They were able to find a pattern. They discovered a pattern. As young kids, they were able to find something joy because they are able to find by themselves with no external support. Okay. But very importantly, they did another one, which is a non-working pattern. What is the next term? 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, another sequence. The possible answers, 21, that's okay because you're writing odd numbers, you can say, or arithmetic progression, or you can say it starts with 1 and increasing 2 uniformly. So after 19, it should be 21. So they got another possible result as 31. 31 is because just imagine if the numbers are written in strictly ascending order, that is natural numbers, but with the condition that every number should have only odd digits. All the digits of the natural numbers should be odd. So for example, you start with 1, it is a single digit, it's an odd digit. Not odd number, odd digit. And if you take 11, it contains both the digits to be odd. 13, both the digits are odd. All the digits are odd. So if you go for after 19, you will be getting 31. You won't get 21 because all the digits must be odd. So that is very, very important. But very interesting part is these children, the 3rd standard and 5th standard children, were able to get 20 with an elementary attack, not with a big algebra or anything. So let us see that how they were able to do that. Next term can be 20 for the sequence 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and then 20. Something interesting for the kids. So they took multiples of 19. 19 ones are 19, 19 twos are 32. So it may look elementary, but look at the research. Okay, so they wrote all the 19 multiples because they are at their age, they can do the multiples of 19. What they did, remember our sequence is 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. So they striked out the last digit of the multiples of 19 and they were able to extract the balance, that is 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. It is equivalent to telling that you divide by 10 and take the quotient. 19 divided by 10 gives the quotient. Okay, so it's like this. What is the next number? What is the next multiple of 19? Yes, it's 209. If you strike out 9, get 20. You see so that means the children are able to do. In fact, I guided only working patterns and not working patterns with few examples, but they themselves found these multiples of 19s. It is completely their work. And they just imagine the amount of joy they had in finding this. And therefore, we should not assume a sequence how it will proceed. Undefined sequence will take its own path. That is the actual fact in mathematics. Then you may ask, sir, arithmetic progression. Arithmetic progression is a special word, special sequence. Uniformly increasing, uniformly decreasing. Like if I say quadrilateral it need not be a square. But if I say square, it is a special quadrilateral. So arithmetic progression is a special word. So in mathematics, terms are important. Okay, so therefore I said only the sequence. What is the next term? The sequence, not arithmetic progression. So we cannot assume it is a special one. So it could be 20. Okay, so fine. So that is what they have found. Let us go to the next one. This is something interesting. This is going to be like a puzzle. This puzzle, it's going to be a little battle between visualization and imagination. This particular puzzle I have given to non-mathematicians also who has answered correctly, and M.Tech students. They didn't answer correctly. So I'm not telling all non-mathematician students answered correctly, right? One person answered correctly, was not basically did any big qualification. And what is needed? Only they should have a little idea about the geometric shape. I'm going to involve a circle and a square. So and some counting. So you need to visualize that and imagine. Okay, that is very important, the imagination. Okay, so there is a very nice puzzle here. There's a 3x3 array of dots. Each row has 3 dots, each column has 3 dots, and you have a 3x3 array of dots, 9 dots. Okay, this is a 3x3 square dot grid, you can say. The question is, how many circles can pass through exactly 4 dots in different positions? I'm going to now display the question, but let me repeat that. How many circles can be drawn to exactly 4 dots among the 9 dots in different positions? You can't draw the same circle again and again and count. Okay, so that's the question. Okay, so I hope you have seen this picture. You have visualized it. You need to imagine. But that is the point. We have visualized it, but we need to imagine. And you need to get all the counts. You should not miss any circle. And you can't count the same circle in the same position. It should be of a different position. Remember, the circle should pass through exactly 4 dots among the 9 dots. Not more than 4, not less than 4. Exactly 4. At different positions. Okay. But one thing, in class also, when I'm asking the questions, students intention will be to rush to answer it. That is enthusiasm, right? I will be coming to that part later also. We need to get the right count. We should not miss anything. If you are able to spot a circle, and immediately you'll be joy because you may spot a circle or both circles. But we need to get all the circles. That's very important. You should not miss out anything. So that is very important. So let us see, there should be an approach. Okay, now we have to visualize. Now imagine. Okay, so let's start imagining. This is the first circle. This may be the first circle. According to my visualization, this is the first circle. Mathematicians are good business people. You know, like if you get one, buy one, get a 3 free and all we are seeing in business, like for the garment shops, like that. If you buy one, you get 3 free, get 2 free. Here, if you see the circle, you can get 3 more circles free. Like that, these 3 will get added to your count. Yes, you can move this right. You see that's a different position. So same size. 2, this is the 3rd, and this is the 4th. So let me repeat. 1, 2, 3, 4. Fine, we got 4. Do we get more? Yes. Circle. Okay, because you see that it passes through four dots, exactly 4 dots. And the center is also a dot. But in the first 4 circles, center is not one of the dot in the 9, among the 9 dots. We are not bothered about the dot to be a center or not. Circle should pass through exactly 4 dots. The fifth circle, this is the 6th. Are there more? Are there more? So we need to give exercises to us. We need to keep asking us instead of asking others. I have seen a lot of people I always say 3 disciplines: proper reading, proper writing, proper communicating as important skills that can be done using mathematics. Another point is, more than asking others, we can ask ourselves and take time. Okay, you see, there's going to be a 7th circle. And the center is going to be, you can see 2 dots in the interior, no? That is the 2nd row. The midpoint of the 2 dots, that is going to be the center. So it's the 7th circle. Again, business starts. You get the 7th circle, you'll get 3 more circles free. How? This is the 8th, this is the 9th, and this is the 10th. You don't require any big formulas and all for this. So whatever mathematics I'm telling, we don't require formulas are ready-made, formulations are ideas. So therefore, we will try to work on more ideas like that. So this is the imagination. So only, I mean, these questions gives you, okay, visualization to imagination. These are good questions. Okay, so 10 circles we got. Are there more? Yes. There are more. See. 11th circle. Where is the center of the circle? You see 4 interior dots. And the center of the 4 interior dots is going to be the center of the circle. So we need to practice ourselves and strengthen ourselves in thinking. Look and corner in a topic. And then if you are going to be tested, examine. The examine should be the last thing. First, we need to improve our thinking. And if somebody examines us, then we'll be able to do it. That's all. It's very simple. Now, the point is, so far we would not have thought this circle. I've checked with a lot of people, they come till 10. Some of them goes till 6. Okay. This 11th circle is something interesting. You can see 2 on the top and 2 on the right like that. I mean, 4 dots. Okay, once you get 2 top, 2 left, 2 right, you can have 2 top and 2 left. See, this is a 12 circle. And I can have bottom 2 and right 2. I mean, I'm talking the opposing dots, 2 dots bottom and 2 dots on the right. And bottom 2 and left 2. That's all. You may verify whether we get more circles or not. This is a simple question. First of all, we should understand that is why I'm starting with the basic level. There is a lot of illusions, like in the number sequence and all those steps and terms like this. So this is a very simple exercise. So there are 14 circles that we can. Of course, I'm to do a lot of things. I will skip this. There is a lot more. Yeah. Okay. I'm not able to share. One second, there is little trouble.
Yes, sir. You are a co-host, sir. I think. What is the problem, sir, you are facing?
I'm not able to share the screen. Suddenly it got stopped, right? What happened? You check some error code.
Sir, can you try again, sir, please?
Yeah, 1 second, I will try. It is showing some error. Showing 105035 error. No.
Sir, can you rejoin, sir? Just can you rejoin again, sir? Yes, sir.
This rejoins. Rejoin. Okay, I'll try to share now. Okay, I need to be made a host.
Yes, sir. It's your host.
And I'm sharing the screen.
Yes, sir. We can see now.
Yeah, good. Okay, this is a good example of enthusiasm versus planning. Okay, so I'm going to show one interesting problem. Okay, so where it requires a simple planning. Sometimes what happens out of enthusiasm, and many students are even, because this question is something on chess and king's movement, so people should be knowing about the movement of a king. King in a chessboard. I mean, king can move only one step forward or backward, or left or right or diagonally. Diagonally also it can move one step. Okay, and within the chessboard, of course, not outside. And it has to, and that's different. Okay, enthusiasm versus planning. There's a problem with king moving on a chessboard. Only king piece will be there, and there is something like in how many ways the king can go. Like there is a good problem actually, because it's like a Olympiad problem. But what we need is only a simple planning. Okay, that's what I'm going to say. And mathematics is there, little mathematics. So fine. The problem is, you can see it's a 5x5 chessboard with white and green alternate, unlike white and black. Okay, it's a white and green. It's a 5x5 chessboard. And you see two positions, A on the first column, third row, first column. Column means vertical. Vertically, you look down, and A is there in the first column, and B is to the extreme right, exactly on the third row, that is in the fifth column. Okay, the king should move from A to B in exactly 4 moves. And first we need to read, we should not immediately conclude and start working. Okay, so there are 2 words, that's a difference. One is move, other one is path. The question is, find the number of paths for the king to move from A to B. The king should move from A to B in 4 moves. A path is composed of moves. Please understand, a path contains 4 moves, because the king has to move exactly 4 moves, not more than 4, not less than 4. So that is a path. Path contains all the 4 moves together. So don't confuse between move and path. The question is, the king can move in different ways and reach B in 4 moves. Therefore, there are more paths. Obviously, you are not going to count the path again. So we need to find the total number of paths for the king to move from A to B. So first thing is, we should not have an enthusiasm to rush and immediately solve. And sometimes we try to draw, and you have to draw more frames, or in the same frame you'll be drawing, it will be crossing, and then visual disturbance will be there. You will not be able to control. Therefore, we need to think, plan. How? I am not going to do any, a lot of path drawing and all, but I'm going to do little planning. First thing is, I'm going to tell one theory. There are 4 moves. King is in the first column. The king should go to the 5th column. Let me just bring the king at A, right? Now, what is definite? Please understand, mathematics is a study of fact that is definite. And it will, suspense means it will say it is a suspense. Wherever a definite is there, it will go through the definite. Even whatever you say, physics and other things and all, no? So you are trying to make it as a theorem or law, so something definite. Sum of the angles of a triangle is 180 degrees, definite. What are all the angles is suspense, but sum of the angles is definite. So whole mathematics, logic is very simple. It's more of logic. Go after definite. I am telling you that in the first move, king should move from first column to second column. Don't look at the picture. Why? From first column, it should go to 5th column. So it should go to second column, third column, 4th column, 5th column. So one move, it should move 1 column, next column. Otherwise, if it wanders within a column, it will be wasting 1 move. It cannot go to the 5th column in 4 moves. So king should move to the next column, whichever column it is, in 1 move. So first column means it should go to the second column. Second column means it should go to the third column. Then third to fourth, fourth to fifth. So that's the theory. Otherwise, king cannot go in 4 moves. So that's a theory. That's number one. Then you should not start drawing. Planning. Wait. I am going to put no entries. No entries means cross. There our king is not going to move according to the given condition. Okay. So I am going to just observe the screen. I am going to put intos in the first column because king is not going to move here. Okay. Similarly, in the fifth column, if you look at the B, king is not going to come from there. It is not going to land anywhere on the fifth column other than B. Finally, it is going over B. These are the no entries. So I'm just putting the no entries. Okay, so step by step. First thing is we understood king should, every move it should go to the next column. And the king is going to come to B only from the highlighted 3 cells, one of the cells. You see, I have highlighted 3 cells. That is the last but one. So therefore, king will not come from the topmost of the 4th column or the bottom. So I am putting no entries there. Likewise, king cannot go to the 2nd column's top and 2nd column's bottom. So you need to hear and also see. Okay, that's important. So in all the other places, king can move. That's all. Now the diagram, no entries over. What next? I am going to assign numbers to each cell. What number? Number of paths taken by the king to reach that cell. Number of paths taken by the king to reach that cell. That means, for example, I'll show you. The king can reach this in only one way. I'm talking path, not move, path. Okay, one way, only one path. Simple. Now the beauty is, I am going to put numbers for every cells, the number of paths the king will move. Finally, B will take a number and therefore that is going to be the total number of paths. So this is the planning. Are we doing problem solving? We want a set of models and then we are working on that. That's not planning or relying on something like what I need is, what we need actually in mathematics is very simple planning and some different problems. So that will give you a good thinking skill. Fine. Now we got 1, 1, 1. I am going to highlight one of the cell in the 2nd column because after 2nd column only you go to the 3rd column, right? Sorry, 3rd column. Okay, we are into the 2nd column now. I am going to highlight one of the cell in the 3rd column and then 4th column and then finally the 5th column, that is B. Okay, see that I have highlighted one cell. That can be reached in 2 ways, 2 paths. And it's a very simple thing is you have to add 1 and 1. See the direction, add 1 plus 1, 2. I can go right and then diagonally down or diagonally down and then right. 1 plus 1, 2. So now I got a very interesting thing. Whichever cell I am going to come from, I can add those numbers to get the new number. That's all. So 1 plus 1, 2. Now you see, I am going to highlight a cell. This is going to give you 3. Why? 1 plus 1 plus 1. Okay, so that's all. Now you need not think of drawing. Whichever cells from where you are going to come, you just add. Now see, I'm going to just quickly fill. 1 plus 1 is 2. That's the 2 paths. Remember, these are path numbers. This is going to be 1. Yes, you are right. I can hear mind voices. This is going to be 1. And what about this cell? 1 plus 2 plus 3, 6. You need not draw everything, right? There is one way, the topmost of the 3rd column. Through that, if you come, that is one path for that 6. And likewise, you can add 2 and 3. So it gets added, it gets 6. So you need to just think a little bit why that's happening on your own. And this is going to be 7, 2 plus 3 plus 2. This is going to be 6. What next? Addition, nothing. 6 plus 7 plus 6, 19. But that is not important in the problem. Arithmetic, it's logic. You don't know, we know 6 plus 7 plus 6 is 19. But why do you get 6 plus 7 plus 6? Where do we get 6 plus 7 plus 6? How do we get 6 plus 7 plus 6? That only matters. So finally, it is only simple addition. And you get something like, something like 19. Therefore, the answer for this problem is 19. More than the answer, answering is important. Sometimes we come across final answer and then say, therefore, but answering is a process. Answer is only the final output. So this is a very good problem. This problem appeared as one of the Olympiad also, but when I explained, even a 4th standard kid was able to do it. In fact, I increased my size to 7 by 7 and all I asked. Quickly he was putting no entries and doing correctly. That means the young brains can work. Only thing is they need little guidance and self-thinking. That is also important, right? So this is a very good thing between enthusiasm and planning, because that student, what I told, the beginning, he was giving some number. Okay, he was able to draw very sincerely, trying everything, and he was telling something like 8 or 9 something. And then when I told this idea, then when I gave the 7 by 7, the student was able to do easily. Therefore, the enthusiasm is good, but planning is very important to get on the accurate result. Okay, this is, you have only 2 movements up and right, and A has to go to B. There is no other condition, number of moves and all. And I can just fill, okay, this is 1, and then this will be 2, this will be 1, this will be 1 path, 3, 3, 6, like that. And you can see, if we tilt it, I will be getting like this. Okay, so I'm just going quick. So I'm going to fill all these things. What do you get? You get this. The same thing, if I take a 5 by 5 and start doing, I'll be getting this. Do you see there is something connection happening? Okay, so to start working with this condition, I'm changing the conditions. And do you find something interesting? Yes, this is going to relate to something called a Pascal triangle. I think there should be 1, 1 at the top. That's a little error. A Pascal triangle is nothing but a king's chessboard. Square, six square, something interesting. Okay, so I'm just skipping this. This is about storytelling and all. Oh, this is something interesting. 642. What's happening? Again, it got cut. I don't know what is happening. 1 second.
Yes, sir. Please try to reshare, sir. Otherwise, if you get the same error, you can sign in again.
Yeah. I think I was trying to change the slide. That is why it's happening. I'm trying again. Is it coming now?
Yes, sir. We can see the screen now.
I don't know why it got. Balaji, I have one small this thing, right? This is asking display settings. That is where I think it's
Yes, sir.
getting.
Yeah, slide duplicate, sir. Duplicate slideshow.
But that I press it, it's going on. The share is. You are able to see now?
We can see, sir. Yeah, we can see now.
Okay, fine. Good. So we are going to see something very interesting like direct question versus momentum questions. So before I proceed, I want to tell these are all segments that has been a part of out of the box thinking, and 1 or 2 are not a part of OOBT also. I mean, because these are all ideas keep on pouring. So we have only took 1 portion for the OOBT for 4 levels. There is much more semantics. So this is one direct question versus momentum question. Is very interesting. That is a part of some topic called number builder. I developed a particular topic with this. So let us see what is the direct question and momentum question. Okay, let's travel with threes. This is some interesting question like using exactly 4 numeral symbols of threes. So you have got a 3, 3, 3 like that. Okay, you can do addition, subtraction, multiplication, concatenation. Concatenation means I can make 2 3s together and call it as 33, not adding 2 3s. Adding 2 3s will be 6. 3 and 3 physically placing one next to each other, that is 33. And I can make 3 3s also and 333 like that. But finally I should get 27. That's the question. So yes, so it's possible. 33 minus 3 minus 3 is 27. So using 4 threes, and you should not use any other numeral, only 4 threes. In fact, I should have mentioned that condition also, telling orally. Okay, the next question. Remember, it is interesting momentum. Momentum means what? Okay, so you are just moving on. Like a pendulum has got a momentum, no? Some moving vehicle like that. This momentum questions. So another question is going to come. See, then only we'll understand why it is a momentum question. Using exactly 3 symbols now of threes. Previously, we used 4 symbols. Now only 3 symbols. You should get 27. It's very easy. 3 into 3 into 3. What, sir? It's very easy. Then if I ask 2 threes, yes, 3 power 3 equal to 27. Now I started with 4 threes and no other symbol. You can use any operations, addition, subtraction, multiplication, concatenation and all with 27. And then for 3 threes and then 2 threes. Here comes the next question. Then you should guess. It's just like the lift. 4th floor, 3rd floor, 2nd floor, like that. Next, what next? Only one numeral symbol of 3. You must get 27. There should not be any other 3. In 3 power 3, you have 2 threes. And the expression value is 27. 3 into 3 into 3, there are 3 threes. 33 minus 3 minus 3, there are 4 threes. Only 1 3. You must get 27. Is it possible? But we should know some extra functions like that. And some of the young children may not know, but I have taught them. I told not like the name of the functions. I told them some symbolic represent, and this is the meaning. Slowly, then I told about the name. So it is possible. Let's see how. You have something called 3 factorial. And for the young persons who are attending this lecture, the 3 factorial is nothing but 1 into 2 into 3, 3 exclamatory. So product of the first 3 natural numbers. That's 6. So I put a bracket and then another exclamatory. What does that mean? 3 exclamatory is 6. And 3 exclamatory means 6 exclamatory. That is 1 into 2 into 3 into 4 into 5 into 6, which is 720. And I can take a square root. 720 square root will be, square root is nothing but you have to find a number which multiplies by itself, gives this result. So 720 is going to be 26 point something. Because 27 into 27 is 729. 26 into 26 is less than 720. So it is 26 point something. And there is a function called ceiling function. Ceiling is above integer. Floor is below integer. So you'll put like this. And that is going to be what? 27. No other numeral is used. Only other functions and other things are used. So this can be understood by even young kids. So there are some efforts being made to make it as a topic, number builder. I'll give some conditions. These are the conditions. Using this, can you get this value? How many values you can get? So it's not a tough thing. I mean, as a part of out-of-the-box thinking course, I'm telling. So this is something interesting. These are all something like momentum questions that makes you. That means always we should be a curious learner. That's very important. Curiosity, that may lead to passion. Passion may lead to success. For example, if you take all the experts, Sachin Tendulkar, he never planned when he started cricket that I'm going to score 100 centuries in first class cricket, nothing like that. He had a curiosity to learn the subject. He find that is something interesting, batting and all, especially batting in cricket. And he used to play like that, practice nets. And he enjoyed. And then school cricket he enjoyed and suddenly was able to enjoy the district level, regional. And then he went to the state and then, of course, country and then international. Then he kept on scoring. There are a lot of issues also, health issues came, but still he continued. He was able to do 100 centuries in first class cricket or something. So he never planned for that. So the curiosity only gives passion. And passion, and then you have to consistently perform also. That is also important. We should not lose the attitude while learning. So these are all important things. So that is a very interesting. So this is another point is some people used to always ask whether to prove something, why mathematicians are asking for proof, something like that. I told even in the sequence, if you start assuming, okay, for example, 13579, we have other possibilities. If you have only one possibility, if it is a fact, then you need to prove. You can't give an argument. No, only 21 will come after 1, 3, 5, 7, 9. So then I have got counter arguments. I have already told, and the third standard and fifth standard children also have given their perception of the multiples of 19 and other things. Therefore, proving is extremely important. But I am going to show you something, a problem. If this question is asked to any person, mathematician, non-mathematician, they will answer correctly. Very interesting, no? But if I ask them to prove, a mathematician may not be able to prove. Intuition. But how do you know that is correct? They will only say, no, it should be only like this. That way only they will try to argue. So that is, but in mathematics, you please understand working patterns, not working patterns. Those who are listening the lecture fully for others. So I have shown working patterns versus not working patterns. So therefore, one may have to prove, because you have working, you have not working. Therefore, it is our duty to look at both. So I am going to show one problem and definitely will answer that. Okay, of course, two problems. It is the same problem, but 1 second. No. The link is getting open, so taking time. Please bear with us. Yes. Which is the closest point to external point A on the given circle? There is a circle, you see. O is the center. A is outside. You can see here my hand. Okay, that is A. Right? Which is the closest to point on the circle has infinitely many points. Circle means not the circumference. The interior points don't belong to the circle. You should be knowing that. Which is the closest point? How do you find that? Intuition, humans only will have. Tremendous intuition they have. Only the circumstance, I am telling you, circumstance will give you language, will give you all the sense. Of course, that we need to be alert. There will be some opportunities will be provided. We may have to utilize it. See, almost everyone would have got the answer, correct? You connect A to O and it intersects the circle at a point. Now, that point will be the closest. So that's correct. So I have connected. This is like the puppet show. I have to put the buttons. Okay. Right. So this is the point. And P is the closest point. What is the proof? I am going to give a proof now. You see, that's very interesting proof. Okay. This is what mathematics students have to do, because otherwise it cannot be accepted. Okay. 1 second. There is another point I am taking Q. Q is any point other than P. P is the intersection point. I am going to prove AP is always less than AQ. Q is a varying point. Q is any point on the circle other than P. P is one fixed point. But what is P? Intersection of the line segment AO and the circle. And we intuitively got that P is the closest point. That means any point on the circle, any other point Q, AQ is longer than AP. That's what I'm going to prove. Let's see how. You see, I am going to just, you see that AQ plus QO is greater than AO. AO is AP plus PO. Why? Triangle inequality, sum of, the shortest path is AO. If you go around, it is going to be longer. But QO and PO are radius, so you can cancel in this inequality. And you get AQ greater than AP. Wherever it goes, triangle inequality will not change. Over. Okay, like that you can do for the farthest point. So I'll quickly do that. So closest point we saw, farthest point will be, you connect AO and extend it. It's going to hit some fellow, right? We extend it. I think I made some mistake. Extend it. So that is my P. So I've got some buttons which I have to do. I'm sorry. Okay, so how are we going to prove now? It is 1 degree, so you are not able to see the Q. I think Q is not displayed, right? Okay, it's displayed now. So you use the triangle inequality. AO plus OQ is greater than AQ. Now I am doing AO plus OQ. But I can write OQ as OP. OQ and OP are radius. Therefore, AO plus OQ is same as AO plus OP, which is AP. AP is greater than AQ. What does that mean? P is a fixed point. You extend AO and then AQ is any point on the circle. These things we have to write. So AP is always greater than AQ means P is the farthest point. Which is P? The point that if you connect the external point A to the center of the circle and extend it. So there is a proof. Otherwise, your intuition may be correct, you may say, but that is why I'm telling answer may be correct. Answering may not exist or may not be there. So answering is important. Answering means logical reasoning. So that is what this course OOBT will try to do. It will try to develop logical reasoning, no pattern. You cannot expect the same questions to come or something. It's not for exams. It is to propagate what mathematics is all about. That thinking, a theory, mathematics is something nature inside, like science is nature outside. You can think a lot. You can think differently and try to see from the basic level to all other levels. You can think differently. Okay, so now intuition versus proving. Sometimes we get intuition, but you are not able to prove it. Why that is needed? Because our intuition may be wrong. And one simple example I can tell you about Newton. Sir Isaac Newton has the intuition of gravity. He had the intuition of something called corpuscular theory, corpuscles. Okay, that theory was not, it didn't work. Then later on, something on light. Okay, therefore, we talk about Newton's working intuition, but there was an intuition which didn't work. Therefore, we need to understand that intuition may be correct. We need to try to prove, and then only we'll know that whether it is true or not. Okay, fine. This is another very interesting thing about natural intelligence versus the artificial intelligence. And this is something, this is my wordings. Okay, how effectively we need to use an artificial intelligence. Of course, there is a bigger one. I have tried to decode it all into the smaller levels. Okay, and even the course is also like that. So you should not think about the content or something like that. It's all about the ideas. And if you go through the, course, anyhow, I'm going to talk about that course also for little time about what are all the things that is available in the course. First thing is natural intelligence versus artificial intelligence. I'm going to tell a little story. Climbing a hill, a situation. And this is a hill puzzle. You can see that there are some parts in the hill. And Arjun is one person. I don't know whether you are able to read clearly. So let me tell orally. Arjun climbed up a hill on Sunday morning at the foot of the hill at 6 a.m. So at the foot of the hill Sunday morning is at 6 a.m. And he reached the top at 10 a.m. So 6 a.m. at the foot of the hill he started and he used his paths. One portion has been shown, the hill, and finally reached the top of the hill at 10 a.m. on the same day and stayed at the hill station the whole day. The very next day, Monday morning, Arjun started climbing down from top at 6 a.m. and reached the foot at 10 a.m. So it's just the opposite because he stayed there on Sunday and then Monday morning, Arjun is going to start at 6 a.m. top of the hill and he climbed down and he reached at 10 a.m. the foot of the hill. This is the story. Arjun climbed up, that is on Sunday morning, 6 a.m. at the foot, 10 a.m. at the top. 4 hours travel because it's on the same day. Next day, from the top of the hill, 6 a.m., he climbed down, he reached at 10 a.m. He took 4 hours. And so this is a simple story. There is only one walking path to climb up or down the hill. So you can climb up or climb down. There's only one path. Arjun climbed with varied speeds both ways. You don't know, Arjun is not traveling the uniform speed. He travels, he might be traveling faster, he may get tired and then he may rest. He may even order Swiggy or something and try whether the 10 minutes delivery is possible or not. Just on a lighter note, I'm not against any company, but he could do anything. He may take rest. He may drink water. He may take food. And then he can climb again. But finally, he reaches at 10 a.m. at the top. And same way he's climbing down is also going to be with very speed. So here comes the question. This is the situation on Sunday morning and Monday morning. That's Arjun climbing up on Sunday morning and climbing down on Monday morning. Okay. He might have taken a break in between also, as I've told you. Can he be at the same altitude of the hill at the same time on these 2 days? So there are only 3 possible answers. There is yes, no, and maybe. So the 3 possible answers. I know, I could hear most of you may say no or maybe, because we don't know. Right. So let us keep, whatever, but we need to have a strong clarity. It is not that we orally say yes, no, maybe and all. We should have some kind of conviction. Okay, the reason that also should be carried by our whatever we say yes, no, or maybe, right? Let me give another puzzle, which is a hint to hill puzzle. There are 2 Shadabdi Express, one starting from station A and going to station B. Other starting from station B going to station A on the same day, 4 hours of travel. So one Shadabdi starting from A, it started at 6 a.m. and reaches station B at 10 a.m. It's the same like Arjun, 6 a.m., 10 a.m. story. So the Shadabdi starting at 6 a.m. reaches the station B at 10 a.m. It took 4 hours. And the other Shadabdi started at station B and it goes towards station A. 6 a.m., 10 a.m., same 4 hours, same day. So they are coming in opposite route. The route is same opposite directions. So they're on same route but opposite directions. Will these 2 trains meet? If you ask this question, and they may travel with varied speeds, that is also mentioned. Don't say it will meet at 8 o'clock at a place. No, they travel with the different speeds. So maybe 8:10, 7:50, but we know definitely they will meet. They have to cross each other because it's 6 to 10, 6 to 10. Somewhere they have to cross. So if they have to cross, they should meet. If they have to meet, it should happen at the same time. They can't meet one train meeting at 8 o'clock and another train meeting at 8:10. The same trains meeting at different times, not possible. So when they meet, it should happen at the same time. Right? So this we are able to answer, but the Arjun problem happened on 2 different days. Therefore, we may not be able to answer that. Okay, now comes we will have a Chitti rope. Chitti is one of the, character that is, a superstar Rajinikanth's movie. Okay, directed by Shankar. So that Chitti Robo, that I think is a robo movie, I think, to exhibit about how robo can be effective. That's what the movie tells, Chitti Robo. So that is the reason why I put Chitti Robo here. I think that's, but my thing is this Chitti Robo is going to help. How? And remember the hill puzzle. Arjun climbed up the hill on Sunday morning, 6 a.m. to 10 a.m. He climbed up. And Monday morning, 6 a.m. to 10 a.m., he climbed down with varied speeds. Whether Arjun will be at the same altitude at the same time, that's the question. How Chitti Robo is going to help Arjun? In that movie, Vasigaran is other Rajinikanth scientist who developed that robo. Okay. Now, imagine that a story like this. I am now cooking an in-between story now. Arjun is climbing up on Sunday morning, 6 a.m. to 10 a.m. He reached the top. Okay. And Arjun, so let me go back here. Arjun is staying there in the top of the hill. Now, Vasigaran is able to get through satellite all these actions. What actions? Arjun climbing up the hill. Vasigaran. Vasigaran is the make of Chitti Robo, scientist. So he is able to get the data, all the data, how Arjun climbed, what time, 6 a.m. was at the foot, 10 a.m. So he fed this data to the robo. Remember the robo that, whatever we talk, some input has to be given. It cannot act on its own. That's artificial intelligence. So natural intelligence should be feeding something to the artificial intelligence. And some instruction has to be given, right? Okay, you have given the data. What next? Instruction. How to utilize the data. How to perform the data. Now, The robo is fed with the data that Arjun climbed up. Remember, all these things, the satellite capturing data and all happened on Sunday evening. Still Monday morning is not crossed. Monday morning is not arrived. Now, Vasikaran knows the program that Arjun is going to climb down Monday morning is the program. So what Arjun is standing up at the top of the hill at 6 a.m. and Vasikaran goes with the robo and he is standing at the foot of the hill. 6 a.m. Monday morning. Please listen. Imagine. And he is telling the robo, city robo, you walk like Arjun. Okay, already I fed the program. Like Arjun on Sunday. How we climbed up, same manner you should climb. Don't ask if Arjun eats some food, whether robo will eat food. That's a different thing. The robo is supposed to do the action replay of Arjun climbing up. That's all the robo should do. Okay, so that program is given. So instruction is given, already data is there. And Vasikaran did the program. So Arjun is climbing down Monday morning. Robo is climbing up. Robo, which is doing the action replay of Arjun climbing up on Sunday morning. Now, Robo and the real Arjun. Robo is duplicate Arjun. Duplicate of Arjun on Sunday. So will the Robo and Arjun meet each other while climbing up and climbing down? Yes, they'll meet each other. What does it mean? Robo is nothing doing the action replay of Arjun of Sunday. So therefore, this is going to be a definite yes. Definite yes. So this is what we need to think little differently. And in fact, we can, all these stories or some kind of a thing, no, that is some mathematics in it. This will come in another form like intermediate mean value theorem and all. So generally, whenever I teach even calculus or something, this is more than these functions or notations, we can tell some little illustrations and where they can make them understand better and why that is connected. There's tremendous amount of connection between calculus, statistics, everything with real life situations, right? So this is a very interesting puzzle to be solved, right? I don't know what is this. Okay, this is something like on the birthday. Okay, and I need to skip this also. So already have 710, right? This is very interesting. I have to go back actually. This is very, very important. I will tell you why. Dynamic versus static. Static means it's like a photo. Dynamic means video. Nowadays, you see a lot of things in YouTube's videos and all. And okay, entertainment, we are happy. Some new movies, some trailers comes and all. Sometimes trailers may be good, movies may not be good. I'm not very particular about any movie, but point is, dynamism is the way to attract the new generation, dynamic things. That doesn't mean that the teacher has to do all things dynamically. The point what I wanted to make here is, geometry is a dynamic fellow. You are putting on the board or something static. That's okay. We can show a little dynamic, but I am telling the dynamic can be made as a teaching aid or solving problems, something like that. And I found the little research that I have done. In fact, in the OOBT also I have done a lot of geometry, little dynamic. There are some very good problems, like Olympiad type of problems that can be easily understood. It is easily understood by a mediocre student who's actually not having some good connect with geometry. I found the reason was very simple. Because it is static and they were looking on some SAS, axiom, SSS, some lot of theory stuff, content. So through contents, they can't look what exactly happens. So if we show the dynamic, they sense it very well. Then comes the second part, that is how well we can bring it to static. So there are two segments. So we can try to put all dynamic up front, especially geometry. Geometry is more of logical deductions. And geometry is very important branch of mathematics. So I'm going to show a few things that is in geometry. Okay, so this is, we are going to call it as a dynamic geometry. And there are going to be good problems with theorems, I think. And Pythagoras theorem, right? It's a Pythagoras theorem. And the Pythagoras theorem proofs are plenty. But I am going to show one dynamic proof of a Pythagoras theorem. And I'm going to have a triangle ABC with C being the hypotenuse opposite to the blue colored I think it's blue colored right angle, and B opposite the pink color and A opposite the yellow color. That's the angle. I am going to scale the triangle ABC. Scale means the lengths will get scaled. Angles will be the same. That's what is similar triangle. Scale. I call it a scaling. It's very easy to understand. Scaling by A, B, C, like that. If I scale by A, what will happen? Every side will get multiplied by A. A becomes A square, B becomes AB, C becomes AC. If I scale by B, B becomes B squared, A becomes AB, C becomes CB. If I scale by C like that. Now I am going to scale by each, but I am going to construct one small building. Let's see, geometrical building. Number 1. This is scale by C. What will happen to the base? I have just tilted the position. So opposite to blue will be C squared. Opposite to B will be C squared. And then opposite to pink will become BC, because previously it was B. Now I have scaled by C. So B becomes BC. A becomes AC. That is opposite L. I will construct a house, rectangular house like this. It's not working. Oh, sorry. I need to wait. This is the rectangular house. It's constructed, and the top one passed through the right angled corner of that scaled triangle. Now you can see that by little, I mean, of course, you need to know little basics, that yellow will go up and the pink will go up because of that alternating triangle sum property. But then I told scale by B and scale by A. Yes, you can see there is a right triangle on the left and right triangle on the right to the brown triangle, okay, in the rectangle. And BC is in place of C, that is opposite. That means this left triangle is scaled by B. And what are the sides? AB and B squared. What about the right triangle scaled by A? What are the sides? You can verify that. That's all. Pythagoras theorem is proved. This is very new. This proof is already there. I'm not telling this my proof, but this is very wonderful things to be displayed dynamically and students understand. Now you see, where is the proof for Pythagoras theorem? We need to prove that square of the hypotenuse is equal to sum of the squares of the two sides. Is it happening? Yes. See the rectangle. The length is C squared at the bottom. The top, it is B squared and A squared, but the lengths are equal in a rectangle. Therefore, B squared plus A squared is equal to C squared. So proof of Pythagoras theorem. So the next one is, I am going to show quickly, is the Pythagoras theorem by congruency. Again. Okay, this is Pythagoras theorem by congruency, right? Screen is. Okay, you have got A squared and B squared divided into 5 pieces. This I have done with an exhibition actually, but this is already known, but certain things I don't know why it is not becoming familiar or frequent. Frequency is not there. It's very interesting proof. By congruency proof, I'm telling. You have 5 pieces. A squared is divided into, see, 1, 4, and 2. Okay, and B squared is divided into 3 and 5. I mean, I have labeled the piece numbers. How did we divide? That is very important. Do you see that B squared length is B, and then A is divided into B and A minus B. Same length B. The second square, smaller square is B here. So that A is divided into B and A minus B, and you are connecting to the corners as shown. Corners of, corners of one of the big square and the one of the small square as shown. It divides that into 5 pieces. And do you see a right triangle on the leftmost? That is the one piece number 1, ABC. C squared equal to A squared plus B squared is what we need to prove. Now I am going to prove that A squared is the area, B squared is the area. These two areas are divided into 5 pieces, 1, 2, 3, 4, 5. If I reassemble the pieces, area will not change. Simple theory. You reassemble. For example, I have some objects on the table. I change the object's position. The count will not change. I like that if I reassemble the pieces of areas, it will not change. So I'm going to do that. See, 1 second. I think, yeah, only 1 second, sorry. Okay, so you see now, I am moving this. It will exactly go and sit. Correct? So the one piece will go here, travels. Or I can draw it statistically. That's why I said it is a dynamic. Now, do you guess where this other next piece will go? Not one piece, two pieces will move. Two pieces will move now. I am going to do the sliding now. It is called translation. It is there in the geometric transformation in OOBT. Yes, 2 and 3. Where it will go? It will go and sit here. Yes. What happened? You get a tilted square. So the A squared pieces and B squared pieces reassemble to form a tilted square. What is the side of the square? C. And you can prove that also. It's not a big deal, but you can visualize it now. So therefore, A squared area and B squared area, the 5 pieces are reassembled and form a C squared area. That means A squared plus B squared equal to C squared. We can prove by congruency. These are all very interesting. In fact, what I find is in geometry, first everyone can understand mathematics. This is what I am trying to say. Only problem is when it comes to discipline like writing. Okay, first of all, we don't understand. Sensing is very important. Then comes only notations, writing. There is a way to communicate. It's like a grammar. Like you have grammar in English, Tamil and all, no, right? You have a grammar in maths. You can't simply say these two, this is proved and all. You have to write SAS axiom, SSS axiom, some theorem, some property, coordinates, like that they say. For understanding, for sensing the subject, you don't require all these things. Please understand that. That's what you are aiming at. Okay, so to sense the subject first, dynamic is important. We can think of writing the contents later. Okay, here is another problem. I think I can move on to this problem. Will take little time for me to explain. So this is a good problem. I can show the figure and tell the question because that will take time. Otherwise, I am going to explain the question with the diagram, right? Orally. ABCD is a square. PQRS are midpoints of the sides BC, CD, DA, and AB. PQRS are midpoints. Please hear to me. That's what's given in the statement. It will take time to read. And you are joining like this: A to P, B to Q, C to R, D to S. It divides into some pieces. 9 pieces. If you see, there are 9 pieces. There is a tilted square in the center. This is the fellow center. That is 1/5 of the bigger square. This is what we need to prove. This is a Olympiad problem. This is an Olympiad problem. Sometimes what will happen? If you tell, we always keep asking if somebody tells, is this course good? This course bad. Somebody tells, then we are like, okay, therefore they told it is good. Therefore they told, we should not think like that. This is one problem I am telling you. More than asking, we please develop reading, proper writing, proper communicating. Sometimes the messages are shown. Even I see in my own institute, parents are not reading. It will be upfront, but they are asking. They are always interested in asking, but I never up calls. They ask them to read, write, and all. We need to concentrate on that. Why I'm telling, this is a Olympiad problem of the past, but now it can be a school problem. But why? The level of thinking. This is what we need to bring. See, I am going to prove that it is a very simple problem for all. How? What we need to prove? I have told you this is a square, midpoints and all. The tilted square in the center is 1/5 of the area. Do we need formulas and all? Nothing. We need imagination. We need something. Remember, every point on the border, not the corners, P, Q, R, S are midpoints of the respective sides. So I have got some sliders. I am going to rotate. I am going to stop in between and ask yourself. I may not be able to interact with you, no problem, but I can read minds. Because I know the way I ask questions, maximum answers will be like that. I am going to just do some rotation here. Do you see one triangle is getting rotated? Yes, that is a triangle with RD length. No, one of the side is along RD. It's rotated anti-clockwise. Okay, what's going to happen? Will this go and sit on RA? how much I should rotate? 180 degree. If I rotate 180 degree, will it sit on RA? Will RD sit on RA? R is the midpoint. So RD and RA are equal. Yes, it's going to sit. It's sat. Now in static, you have to draw the construction and say the axiom and all. That is not needed because that is only a discipline, writing discipline, communicating discipline. Sensing discipline, we need dynamic. That's all. This is what I am going to do a little research. Okay. And in fact, with, we can even enhance OOBT and all. The point is, everything can be made dynamic, then it becomes easy for the students and more people will be interested. Now I am going to do beta. Alpha is rotated over. Beta. Yes, you are right. I am going to rotate AS. It will sit. Yes. You can guess what is going to happen at the next angle. Yes. PP will sit over PC. What will happen with this? What do you see? Oh, the pieces are reassembled and it looks like, of course, there are little proof and all required, but I told there is an intuition. The center square is surrounded by 4 squares, all looks identical. Oh, these 5 squares only were pieces brought from the bigger square. That means they are equal pieces, means every square is 1/5, including the central piece. Correct? Over. Only thing is we have to write. So therefore, we should not think that nothing is tough or nothing is easier. Both ways. Now I can show you that in a single thing. Done. This is like that's why I said the Olympiad question of the past. So we need to improve our, I mean, as far as the teachers are concerned, we need to have a pedagogical challenges there. One of the thing about geometry is, so you can feed the dynamic first and then static next. Of course, we can use something like GeoGebra. And of course, there are a lot of things to be programmed. Programmed means you have to do a lot of constructions and set rights the characters and all. But the thing is, it becomes one attempt because if you do it for this year, next year also you can teach your children. And you can add on parallelly so that more bank will get added, dynamic bank. Okay, so that's a very interesting problem. And let us move on. This is another very interesting. There's a convex quadrilateral. So let me go to the diagram and do it. Yeah, this is like a convex quadrilateral. There are some conditions actually. And it is, you are taking the midpoints of each side. Okay. And you can connect the opposite sides, the line segment connecting the, the midpoints of the opposite sides. You get 4 pieces. These 4 pieces can be reassembled to form a parallelogram. That is what we are going to see. You see now, the piece 3 can go here. And then I can rotate PB. PB can sit over PA. Then I can rotate this. We'll be getting a parallelogram. So that means any quadrilateral is, if you mark the midpoints and dissect into 4 pieces, it can be reassembled to form a parallelogram. You can try all these things practically. That curiosity should be there. This is what I told. If you don't have curiosity, you cannot develop passion. Some people ask how to develop, Means first you get to act. Okay, then you will develop. So this is, of course, I can change this and then do. It will take time. So this is a lot more about geometry. So this is one quickly I can show you. This is something interesting. One second. Okay, so I will tell the problem, what the problem is all about. You have a triangle ABC, and then you have drawn equilateral triangles on either side. So what you may have to prove is that you get something like PQR are the points on the equilateral triangles. You have to prove AP equal to BQ equal to CR. It's like a Olympiad problem. Okay, again, I have got a lot of buttons, so I need to check. Okay, first I am going to show you that. Yes. You can see the triangle here, ABP. I'm going to rotate this triangle by 60 degree anti-clockwise. So you can see that AB will go and sit on BR. What will happen to BP? That will also sit on BC because you see 60 degree. Look at the figure. It's all equilateral. Therefore, 60 will be there. And if I rotate, superb. Now, AP will be moving. AP is tilted. AP, A to P. Look at that. It goes and sits over CR. And 60 plus B is covered. That angle included. Therefore, AP equal to CR. So that we can do. And what next? I got another triangle BCQ. Then I can similarly rotate. Now what happens? BQ can sit over AP. So all these things can be done dynamically. And even the big Olympiad problems or something can be made easier. So only challenge is how to, it's not a challenge. Once you understand, there is only a particular grammar in which, so I can call it as a grammar. All these axioms and other things, CPCT and all, it's like grammars. So if you understand grammar part, that is requires a separate discipline. You have to, whatever you think, you have to put it in a proper grammar and write. So that is different at the school level. But as far as understanding maths is concerned, this is where, OOBT is going to help you. You can understand a lot. And it will be nice, it will be interesting, but at the same time, it will be challenging, it will be engaging. Okay, so that is what all about. So fine, let me go out. We have got only little time. So I am going to talk about this. It is a lot more actually, but I want to tell you only this part, right? This is connect and disconnect and connect. Okay, so I will tell you a very simple one. This problem I am going to not use board, but this is like algebra. I have shown geometry now. Okay, 20 chocolates need to be distributed to 2 children. Actually, need to be distributed to 2 children. How can we distribute? We can distribute in many ways. I am talking mathematically. 10 chocolates to each or unequal number of distributions. Simple. 10 each. Or one gets more than 10, one gets less than 10. Both will not get more than 10. That's all. So mathematically speaking, 20 chocolates can be distributed to 2 children in 2 different ways. One is equal, other one is unequal. If unequal, there will be a lot of, if you go by numbers. Similarly, if I have a problem like sum of the squares of 2 consecutive odd numbers, remember odd number square, 290. Find the odd numbers. I say one square is greater than 145. Other square is less than 145. By the chocolate property. The chocolate property, what you say, 20 chocolates should be given to 2 children, so one gets more than 10, other gets less than 10. So theory, fact. So sum of the squares of 2 consecutive odd numbers is 290. One number should be more than 145, other square should be less than 145. Look at which odd squares gives. 11 squared gives 121, 13 squared gives 169, but you need to verify whether the given data is correct or not. Therefore, the odd numbers are 11 and 13 because 11 squared is 121, 13 squared is 169. No need of algebra. So there is a topic called where is my friend X? Is a topic in OOBT. So all these things you can learn, which will help you. So some people are asking, no, right? Help you because you need not even use X. If I project the problem to 5002, same logic. Same logic. 1 square is less than 1 square less than 2501. Other square greater than 2501. Okay. 2501 is closer to 50 squared. Therefore, you need to verify 49 squared and 51 squared. If you want, you can do this. There is a quick way doing, I think it's 2401. You can add. Why do we need x squared, x plus 2 whole squared, quadratic, and then minus b plus or minus all those things? I am not against all those things. Why do we need that? Why can't we include all these things? So this is what is going to help you. Okay, that logical thinking. So there are other ways to think, which I am not telling this is something great. There may be more. If you keep discovering these kind of rules, something more can emerge. Okay, so this is about disconnect and connect. Do you know why the topic was disconnect and connect? Because I am putting vessels. 20 chocolates is like a different question. Some of the squares is like a different question. So there is a disconnect like that. But the connection is, I said the equal and unequal distribution. That logic I can use. Okay, so fine. There are a lot of questions. Yes, so I'm going to just quickly tell about this out of the box in the next 5 minutes. Anyhow, the details must be there. So out of the box thinking through mathematics is a course that is a national project. It's an initiative of IIT Pravartak Technologies Foundation to nurture young minds across ages, because it's a different course, because this whatever problem I tell, some of the people who have studied the school education or something would not have done problems like that or thought like that. It's not about examination or anything. It's about the thinking only. So that's why it's out of the box thinking through mathematics. Okay, so this is a very interesting course, and with my experience of doing some different kind of problem setting and all over the years, and seeing students have been successful in many other branches. So they are the ones telling that it's working. This thinking has helped them in other fields also, right? So the point is, so after, it has come into the shape of out of the box thinking after several rounds. It's not like so many years. Okay. Right. So this initiative taken by IIT Pravartak Technologies Foundation to nurture young minds. So I must thank IIT Pravartak for organizing this session also to reach you people, right? And also for the initiative taken. So, and there are a few things I want to read out. So I don't know whether you are able to read it properly. So a New Zealand and Australian Olympics team took mathematicians as a part of their Olympiad team in 2016 Rio Olympics. Mathematicians. So now, importantly, the statisticians are going to play a very important role. And there are a lot more I have to read about OOBT courses and all. It is new, inspiring, challenging, and engaging. So it will be challenging, but it will be new, it will be inspiring. So it is going to help you for the modulating industry, because that requires a different type of thinking, ready mindset to face challenges and all. So therefore, it is important, right? Okay, so this is for class 5 and above level 1, 20 hours. 5 and above means somebody in 11th standard also can do 11-1. But 11 and above level 4, that cannot be done by a class 5 student. So the reason is the knowledge required for level 1 is whatever you know till class 5. But the topics will be different like that. So it's not only for school students, it's for teachers, it's for anyone, professionals. So anybody interested can get into it and see what is this all about. It's 20 hours and 10 weeks, 20 hours. Every week, there will be 2 hours of content will be posted like that for those who have registered. And this year, this is the 3rd year actually you're running. So 2022, it's been launched, and almost about 2 lakh people have registered in different levels and benefited. And those who have registered, good. Those who have not registered, please register. And of course, if you register, you need to spend only little time, and that's going to be very useful time for you. So class 5 and above is 20 hours. So there are occasions where 80-year-old and daughter-in-law and grandsons all took level 1 and came and took test also, right? Test is optional, but it will always be a test will help you to know where you stand and all. So level 2, level 3, level 4 are put there. Level 3 and level 4 at 30 hours, but level 1 and level 2, 20 hours each. So 4 different levels have no upper age limit. They are independent. It's not connected. One, if you do only one, you should go to 2, nothing like that. But I prefer anyone, even students of 10th standard or 11th or even college students, they can, if they are new to all these things, it's better they start with level 1, level 2, like that. These courses are online and one can do at their own pace. Level 1, it has topics like puzzle maths, cow grass theory, follow the sequence. There are a lot of interesting topics that you have. Frog jumping theory, cows and bulls story math, where is my friend X, number builder, jolly ride with modulo, that is in level 3, graph man, chasing the ratios, coloring math, vector, the powerful arrow. You will have vectors, complex numbers, imagine the complex, but it will be different from what you are learning, but it is connected also. For example, this I told the quadratic equations can be solved fast. If suppose you are doing some competitive or something like that. But first thing is not about the exam. If all this logical thinking will help you to do things better. Okay, so courses are free online. As I told you, 10 weeks, 13 topics, and 20 hours for recorded lectures for each level in levels 1 and 2. 3 and 4 has got 20 topics, but 10 weeks only, 30 hours. So 3 hours per week. And you will have periodic assignments. Every 2 weeks, you will be getting assignments. There will be evaluation, assessment, and detailed answers. You have to make a self-reliant is important. When you say, where is my friend X? A friend in need is a friend indeed. It's okay. But you should not always be in need of a friend. That is the point. A friend in need is a friend indeed. But we should not always be in need of a friend, AI, chat GPT like that. Whenever there is a need, we will use it. We are the, we should have that, what you call, self-reliant. That is very, very important. So we need to do the assignments and try, and then look at the answers like that. That's always going to help after watching the video lectures and all. Okay, so this is about the courses and all. And of course, even cracking international Olympiad competitive exams, the students have done. I mean, because I have already told you, students who have come across all these different thinkings and all with properly following. That is very important. They have benefited in exams also. The primary agenda is to, enjoy the subject. Okay, so the levels are commencing from August 10th and we are in July end, July 31. And I hope that you can enroll and enjoy. Another point is going to happen every year. So therefore, if someone is doing this year, and suppose they are trying to test themselves with an exam or something, and there are grades also, I can show you that there are grades. Grade A, 85% and above, grade B, 70% to 85%, grade C. This is about exams. Exams, we need exams only have to pay nominal fee, and it will be conducted across centers in select cities across India, and courses free online. That will be posted from the IIT Pravartak web portal, where you have to visit, and then you have already registered, so you'll be receiving mails and all. Keep checking the mails. That's very important. You cannot register on one day and nothing is coming. Means you have to keep checking the mail, and you have to check everything, even spam and other things. You have to check everything whether getting or not. There are some contact numbers and other thing must be having. So you can always be in connect to see. So as far as the exams concerned, if you are going to write, and then if you are not getting to 40% or above, you may not get a grade. No problem, you will get the knowledge, but you can try again next year. That is, so the 100 hours you have, which is going to be potential 100 hours for utilizing and learning, that's going to help you build your tremendous thinking. Remember, I told one person, like in one of the college, it's like a lot of apps are there in a mobile, but if you don't have power, suppose the battery gone for 0%, no app will be working. So the battery should be charged. Like that, our out-of-the-box thinking should be charged. Any field you are going, apps is like any field, whatever you are going to engage in the future. So therefore, if you are always charged in thinking, you solve not like whether this problem is directly connected or not. It's okay, it is connected indirectly or something. But your brain has been charged every time when you are doing a problem, whenever you are doing something different, because these exams are going to be not like the model assignment questions and all. It will be on the same topics, but with a different type of testing, right? If you come out of that, that means you are always charged and you will be ready to discharge. That's what is needed for the future in this industry. And also you try to utilize the courses, and also, even exams, you can see that the centers are there, and nearer to a place, you can select all those things are there. Okay, so this is the website, that iitmpravartak.org.in/out-of-the-box thinking. If you don't have this link, you can just go and type out-of-the-box thinking or OOBT, IIT Madras, it will take you there. And you can contact us at oobt@iitmpravartak.net, and these are the contact numbers. And this has been taken care by both Bridge, and they are the ones who have been supporting for this session. Also, I must be very thankful to both Bridge for giving me the opportunity. Okay, organized by IIT Pravartak. Okay, so this course is inspired by my friend, and the person is here, is known to me, and he has achieved a lot. Kamakoti sir, the professor, director of IIT Madras. So the important thing is IIT for all. That is his agenda. So he wants to reach out to a lot of people. Already you must be knowing about the data sciences, so many courses. It's amazing person who wants to get to reach a lot of people and to get more benefit. And there's a tremendous vision and the mission also. So that is what I am. So this OOBT is because of Kamakoti sir inspired. And because we have done together something like beautiful mathematics and other thing before. is known to me, right? And he has been watching closely, monitoring the problems. He wanted me to put it into the form of a structure and then bring out all the syllabi into different levels. In fact, I could make 66. I can double it. I have still more topics and all. But the interesting part is you have taken these 66 topics together from 4 levels. And of course, there can be something more also. So whatever the best you want to reach out to students and see that mathematics is more connected to logic than arithmetic as the other way it is being perceived. And he is one you must be knowing about there is a related to the computer science, AI, data sciences, and all those stuff. So he sees a lot of mathematics background is needed for that. That's the reason this course has been. So thanks to Kamakati sir for being the inspiration behind this important venture. Important, I should say. More than liking, disliking, you please understand it is an important venture, OOBT. Okay, so, and this is going to be the last thing. There's a cab number 1728 is also a special cab number. If you are going to put 1728 like this, and then anti-clockwise and clockwise, you take 2 digits at a time, you get 17, 72, 28, 81, and anti-clockwise is 18, 20, 82, 70, 27, and 71. You add, you get the same result. Some of the squares also will be same. So it is very interesting. We all know about 1729, but it is 1728. Okay, that is interesting. But is your vehicle number special? You can verify that. So what I have told it in a little bit rush. You take the 4 digits and then put it clockwise and anti-clockwise, and the 2 digit, two digit you have to take and then add them clockwise, anti-clockwise. Some of the squares also it will be same. You'll be surprised it works for yours too. Every number is special. Every object is special. Every animal is special. Every human is special. Every creation is special. And let us all work towards creative India while keep enjoying mathematics. So I end up the lecture, and thanks to one and all for patiently listening to the lecture. And in fact, your support is needed, very much needed to make towards creative India, because you need to participate and see what exactly it is. Instead of asking whether it is useful or not, if you use it, it will be useful. That's what I can say. So please enroll and register in OOBT and make the benefit out of the most towards this national venture. So thank you very much. And stop listening.
Yeah. Thank you, sir. Thank you for this wonderful session. Very happy to have you today. And we had a very interesting session. I believe a lot of students have been watching this session live for a long period of time. Thank you all for joining this session. Thank you, sir, for taking this session continuously, almost 1.5 hours.
Yeah.
Thank you all for joining this session. And this session is available in YouTube as a recorded format. You can access it later as well. Thank you.